Imagine you are trying to predict the weather. You have a thermometer recording the past week's temperature. That is your time series. But you also have a meteorologist saying, a cold front is coming. That is your text data. Most people today just take the meteorologist's words, turn them into numbers, and average them with the thermometer readings. Not the smartest of approaches, come to think of it. You should use the words to change how you interpret the thermometer. If the expert says cold front, you adjust your prediction model downward. That is what we are doing here. We are not just adding text, we are using it to control the machine. Look at figure 2. The top shows a standard fully connected layer. It is just a grid of pipes connecting inputs to outputs. The connections are usually fixed after training, but the world changes. So in the bottom half, we cut those pipes. We introduce a latent layer in the middle. Think of it as a set of valves. The text data, our news, controls these valves. We decompose one big layer into two smaller ones, and the text decides how much information flows through the middle. We are routing the signal based on what is happening in the news. How do we actually turn a news article into a valve setting? That is figure 3. We take the text and squash it into a vector. Then we run it through a small neural network. But here is the trick. Raw data is noisy. If the news is slightly different today, we don't want the valves jittering around. So we use vector quantization. Think of it like a guitar tuner. If the string is a little flat, the tuner snaps it to the nearest perfect note. We snap the text signal to a code book of stable market states. This gives us a clean, steady hand on the controls. Now, attention mechanisms are the workhorses of modern AI. They let every data point talk to every other data point. But how do we guide that conversation with text? We can't just use the valve trick from before. Instead, we split the attention map. We introduce learnable latents. Think of them as switchboard operators. The input calls the operator, and the operator connects to the output. The text tells the operator which calls are important right now. We are physically altering the path the information takes through the attention mechanism based on the external context. You cannot just feed raw newspapers into a math equation. There is too much noise. Figure 5 shows our refinery. We use a large language model like a sieve. First, we filter out the junk. Then, we identify the specific events of the day. Finally, we ask the LLM 2 questions. What is driving the market right now? Key drivers. And what do you think will happen? Outlook. We distill millions of words down to these potent, concentrated signals before we even let the forecasting model touch them. Here is the whole machine assembled. The authors tested this on 2 types of engines, TS Mixer on the left and iTransformer on the right. They plug the AIR modules directly into their layers. Notice a small detail. They use the key drivers text to control the feature extraction, understanding the present, and the outlook text to control the final predictor, guessing the future. It is modular. If we take a good engine and add our text-controlled fuel injection system, it adapts to the road conditions in real time. The results in Table 1 are clear. AIR consistently beat the other methods. It didn't matter if we used a transformer or a simple convolutional network. Adding AIR improved accuracy. Why? Because we aren't confusing the model with extra noise. We are giving it context. When we added that guitar tuner quantization I mentioned earlier, the results got even better. Stability matters. So, what is the big idea? Don't treat text as just another pile of numbers. Treat it as instructions. We built a system that reads the news and physically retunes the forecasting model's internal pathways in real time. We use LLMs to clean the data, and we use a clever decomposition to inject that data into the heart of the network. It turns a static, rigid predictor into an adaptive, context-aware forecaster. It is simply a smarter way to mix modalities.